Welcome. Today we are discussing Module 9.2, Implementing Cross-Encoder Re-ranking, Practical. Here is a quick look at where we are in our curriculum. Welcome back. If you are running enterprise RAG pipelines, you have likely noticed that simple vector search often returns irrelevant documents that confuse your LLM. To solve this, we use a two-stage retrieval architecture. First, a fast Bi-Encoder retrieves the top 100 candidate documents from our vector store. Then, a computationally heavier cross-encoder re-evaluates those candidates to surface only the absolute best matches. Please check the link in the description to download the architecture diagram and script for your own projects. Let's break down the execution flow of this hybrid setup. When a user sends a query, our RAG orchestrator first hits the vector database. We pull a generous set of unranked nodes to ensure high recall. We then pass this set, paired directly with the original query, to the cross-encoder. Because the cross-encoder computes joint attention, it spends more operations per candidate but yields highly precise relevance scores, which we sort descending to feed the LLM. Let us look at how this sequence executes in practice. Now, let's write some production-grade code. Here, we import the cross-encoder class and load a highly efficient pre-trained model. We define a sample query and a list of retrieved documents, including some highly distracting but irrelevant options. By forming query document pairs, we can run a single batch prediction call that outputs exact matching scores. If you want to deploy this locally, remember to check the link in the description to download the architecture diagram and script. Whoops! Looks like we've hit a classic live debugging moment here, which is actually a fantastic teaching opportunity. As you can see from our traceback, we've encountered a module not found error, no module named sentence_transformers. This simply means that the necessary Python library for cross-encoder isn't installed in our environment. A quick pip install sentence transformers will resolve this. Once that's taken care of, and assuming our script runs as intended, we would have seen that the cross-encoder easily identified the document about hybrid search setup as the absolute best rank, scoring it highly at 0.89. Conversely, the completely unrelated context about a protocol would have been safely pushed to the bottom with a strongly negative score. This clean separation ensures our LLM only receives context that directly answers the user's intent. And now you know how to fix a common installation issue. When moving this architecture to production, latency becomes your biggest enemy. Unlike Bi-encoders, where vector similarities are computed in microseconds via flat indices, cross-encoders pass every single candidate through a neural network at query time. For scale-out web applications, you should restrict the re-ranking candidate pool to 30 or 50 documents. This keeps your response time stable while capturing most of the precision benefits. To mitigate performance bottlenecks, we must write optimized inference code. In this optimized script, we configure GPU support and apply strict batch execution. By passing a configurable batch size to our predict function, we leverage parallel GPU hardware, minimizing overhead. Don't forget that you can check the link in the description to download the architecture diagram and script for your production cluster deployment. Whoops! Looks like we've hit a classic live debugging moment here, and it's a perfect teachable instance. As you can see from our traceback, we're encountering a module not found error for sentence_transformers. This simply means the required library isn't installed in our current Python environment. A quick pip install sentence transformers would fix this right up. It's a common hurdle when setting up new projects and a great reminder to always check your dependencies. Now, assuming we've swiftly handled that installation off-screen, let's get back to the exciting performance benchmarks we were about to review. On standard CPU execution, processing 50 pairs sequentially could take several hundred milliseconds. However, by enabling CUDA acceleration and utilizing a batch size of 32, our optimized script completed the entire re-ranking operation in under 0.08 seconds. This simple change makes your advanced RAG pipelines fully viable for interactive web applications. To summarize, combining Bi-Encoders for fast retrieval and Cross-Encoders for precise re-ranking is a gold standard for production RAG systems. It minimizes hallucinations and keeps your operational costs low. Now that you have mastered the practical implementation of re-ranking models, we are ready to move from single pipeline data search to unified data interfaces. In our next session, I will meet you for Module 10.1, Model Context Protocol, MCP, Intro, Theory, where we will discuss how to standardize context connections across AI applications. See you there.